Hey, good morning, everyone. So, thank you for joining this session. So, I'm excited to talk about developing the smart agents using AI. So, like in this session, you will be going to understand how we can build an AI agents using LangChain, and also I'll be going to cover a little bit with OpenAI SDK. With that, I would like to jump in. So my name is Seetaram Rao Rayarao. I have worked in JP Morgan Chase. I have like around 20 years of experience in IT, and I would like to put a small disclaimer here. So whatever the views that I share here is solely owned by me and nothing to do with JP Morgan. So yeah. So like why the smart helper is matter, right? So basically the when you're building the agent, like earlier we have a chatbot which is in static in nature, and with this AI comes in, agents comes in, where you can build your own helpers, which is like proactive in nature, so which will understand your context, and it will use a certain tools. Like I'll come to what is tool. So if you want to interact with some of the external APIs that you can do with the tools, and they can do like any question and answers and stuff. And we can also build a RAG system that I'm not going to cover in this, but it will give you the more context to A, which will take what exactly answer your questions. So with that, I'll move to the next slide. And what are the core building blocks of building an agent, right? For like when you see an agent, it has its own perception. So what is a perception? It's an ability for the agent to gather and interpret the information that it captured through the APIs, the data streams, or it can be S3 bucket or anything, right? Once it is having this data, it requires of a good amount of reasoning. So what is reasoning? It's about thinking, like how we as a humans we think. The agents will also think in the background, and they make the decisions out of it. So once it comes up with a plan or a reasoning steps, then there will be actions. So based on the reasoning, it is going to take some certain actions. So this makes agent more like a human, right? It is able to get the data, think about it, and it is taking the action. And what is the beauty in this is it is able to take the feedback, and once it receives the feedback, it is going to work on that feedback, and it can go back to take some more actions if needed, or it is going to end the process. So with this, like if you see the AI agent, right, it is able to like robustly able to think, get the data, think about it, and take the actions, and also work on the feedbacks. So now like I will be going to cover how does an agent work, right? So if you see the AI agent, like in the center of that thing is an AI agent. So it has some tasks to do, like a human will provide some task, like I need to do something. And also you will have the system prompts. What is in the system prompt? System prompt is a default prompt, like you will tell the system AI agent, it is building on the LLMs, right, large language models, so which takes the input from the system prompt, and it will basically act based on the system prompt. If you want to have any prescribed way to respond, you need to put all the instructions in the system prompt. And it has a memory in it. What is a memory? Why it is important? When you are building the multi-agent or multi-tools, when agent is orchestrating the communication among all these tools or agents, it has to store the conversation or history into this memory. And also it has like capability of reasoning, plan, and act based on the decisions that it make. And the tools is a part which made so lot of power. It is adding a lot of power to the AI agents. Why? Because the AI itself is trained on some old data, and if you want to get your real-time data, for example, if you are working in an enterprise, right, so you need an enterprise data to be feeding to your system. How it is done? Using the tools. So in a short span of time, I'm going to show like how these AI agents we can build using these tools. Now, like I'll be going to cover how the orchestration and the workflow is designed. So if you see, there are some nice patterns that we have today. So how these LLMs can be orchestrated, or how we can develop these AI agents, right? So for example, when you are seeing the routing, you will get a input to the LLM, and it just routes the traffic to the different LLMs, right? So here this A agent, that is LLM call router, is a simple agent which will just route the traffic to the next LLM call, and it will finish the task. So this is like a simple step. And evaluator optimizer, like when the AJ agent LM call generator is an agent which will which will work on some action. Then once it provides to the evaluator is another agent which is going to take the input from this generator, and it will get the input, and it will work on that feed. It will work on it, it will analyze, and it will provide the feedback to the LLM call generator. Like in this one, there is a feedback loop is going on until this is satisfied, the condition is done. It will keep looping here, and there are good amount of chances that if you are not handled well, it will go infinite. So there should be a good guardrails to make sure this is not going infinite times. And once the response is accepted, it is going to be published in the output, right? So, and another good technique is the prompt chaining. What is prompt chaining? You have an input, and the input is given to the LLM. The LLM, I mean LLM agent call is going to make a call. There will be a gate, right? So based on this gate, it will turn to the next agent or it will fail. So basically the prompt, like the gate will act as a, like whether to chain or it will stop chaining, right? So the output of one call will be given to the next call, right? So here in this case, the LLM2 call is sent it to the LLM3, right? The LLM1 output is sent to LLM2, LLM2 is output is sent to LLM3. This is where you are chaining the response till you reach the desired outcome. And the most powerful thing that I like most is the orchestrator. This is in the production grade applications, right? So we use this orchestrator way of dealing, right? So you will have the user which will prompt. They ask agent to perform some actions, and this orchestrator will decide what agents are, what LLM calls I need to make. It can be agent or it can be tool calling. I'll be going to cover these terms, but imagine like they are going to call another agent to get the task done, right? For example, if you want to go a travel planning, right? So you can give it to the orchestrator saying that, hey, I need to travel to some location, and now this orchestrator will decide, okay, in order to go to that place, okay, what is the weather condition there, what are the places to see, and all these are different APIs, and these are different agents. And then there will be a booking agent, maybe it will book all the all the travel thing, whatever you needed, right? So itinerary, basically it's going to build, and the synthesizer will capture all the information that from this all three agents, and it will synthesize it and give it to the output. So in this, now I'm going to cover in a demo. In that, I'm going to use the evaluator optimizer and orchestrator, these two patterns, because the feedback loop is important, and the orchestrator is the where the actual work is delegated among the agents. Now you can ask me, right? So there are different, now there are so many ways that you can create an agent. There is no one way to do that. So if you see, there will be Agentic SDK. So SDK is a software development kit, right? You can write your own code. This is my favorite way to write, right? You have a lot of customization that you can do. And no code, low code, nowadays there are so many studios are coming up with, you can, without any having the good amount of experience with coding, you can also develop agents. But in this session, I'm going to cover like how we can use SDK to develop the uh, uh, agents. So if you see that features, right, we have customization, learning curve, scaling, debugging, and ideal for, if you see the SDK approach has a lot of tick marks, whether no code has very limited customization. So this is another factor why I choose SDK rather than no code. Now, like, let me go over like how we can create an agent, right, with using OpenAI SDK. So in this, like you will see, the agent consists of three building blocks. One is a model, like that is the actual model which has trained on good amount of data. For example, the frontier models like for OpenAI is GPT 4.0, 4.1, 4.1 and 4.0 mini, all these things. And you can use like Amazon Bedrock, any of the LLM model. That is a core of developing the agent should have a model in the back. And this is the actual brain, right? The tools, like the tools, what are the tools? It's, if you think like it's a function calls or external APIs that you want to call. As I took the example of creating a travel plan, for that one, if you think you need to make a call to uh, Google Maps to find out the places, maybe Google Places to find out what are the good places to visit, and you may need to call weather app to find out how is the weather condition, is it like indoor or outdoor activity is better. All these things you can club them as a tools, right? So the agent has get the power with these tools. The tool will be used by all the agents. One agent can use one tool, multiple tools. It depends upon how you are going to define your agent. So, and the instructions, like you will provide a system prompt or instruction to the thing, right? So, like here in this case, I took the example like you are a research assistant. For example, if you are doing some research, right? Given a research term, you go to the web online and find out what are the relevant information available in the internet, right? So this is how the system prompt you can feed in to the agent. Now, how do you create an agent using SDK? It is very simple. You have a SDK. You need to install. I'll show how I did it in my local. So there will be an instance you are going to create. Here in this case, it's a search agent, and you are just defining the agent and passing the name, instructions, what instructions you want to pass, and what are the tools, right? Web search tool. Like I'm using the web search here to just one tool. And what model you are going to use. So each, you remember each agent is backed by model. So this is the model we are using, GPT-4 mini. And you have model settings, like if you want to define any custom settings for that. And how do you run the agent? Like you just pass like runner.run and search agent with the message. Message is the input text. For example, I want to do research on AI in 2025. You can do that. I'm going to give the demo soon. So this is how you define, you create a agent using SDK. Now, demo time. So let me show you this example. So if you see, I just build a small agent. What does it do is like it's a multi-agent research assistant. So I provide a topic. So for example, there are suggestions I captured already. Latest development in the AI regulation and policy in 2025, or you can ask any of this question. What does it do is it goes and does the analysis, and I'm going to capture here what it is going to happen. In a minute I'll show. So it will find out what is the trends and what is the web search it does. Then it will give to the another agent to do the analysis on whatever the information is captured. Once we get that information, I make sure that is it like I will give the ranking based on the information that I got. So it's kind of a judging, right? So another agent is going to judge the work that is done by the first agent. So it like it is a multi-agent thing. So yeah, let me give the quick demo, right? So here now I'm going to call these latest developments happening in the A 2025, right? I'm starting the research. Now if you see, it is going to make a multiple API calls. While it is running, I'll show you the LangSmith. This is the tool that is used to capture what is happening internally, right? So if you see, it will show the execution flow. Currently, I am using Perplexity to do the search because the Perplexity search is more reliable, and it gets the reliable data from the internet, and it will provide you the citations results back to us. Like I will be going to show how the response looks like in soon. It is going to run. It may take some time because it has to go to the internet and find all the stuff. Meanwhile, it comes. Let me come back to the here and see. Yeah, what it is doing, right? It is finding, like it found some place that it needs improvement. So this is the feedback it got. So it is still working on in the back end. Okay, now whatever the research I have done by one agent looks like it requires feedback, and there is an improvement. Like after that, now it is improved. The report whatever we got, it's improved. So how the flow happens here, I'll go over. Like for the research work flow started, it's after starting that I'm giving to the perplexity research agent, which is going to do some findings in the internet, and it will give back to the analysis. This is another agent running. So basically this will go and find out the analysis of whatever the research, whatever the um, information we got from the perplexity. Then we are giving to the fact check. So there is another agent which is going to do the fact checking. So once this fact check is completed, then I'm doing the quality of the check. Now this quality checker will give the score of 0.69. So this is now under the threshold, right? So it thinks that there is a scope for the improvement. So the improvement agent, so it is saying that it requires an improvement report improve, and it is like, and here the dollar cost is the, I'm calculating how much dollar it cost for us for the each step. So it charged me like 0.0012 cents. That's a very small amount. So then I'm going to generate the report. I'm generating the quality check on this report. Then to come to the final stage, right? Now the score is improved to 0.77. So there are like multiple revisions happened over the time. So how this happened is using the feedback loop. So one agent is sending this report to another agent, ask another agent to review, as like we are humans reviewing that report, and it found that there is a lot of improvements needs to be happen based on some criteria that are system prompts that I've provided, and it reviewed that results and gave the quality check. So let me go to the code and show you internally how this is working. So this is a graph, like I used a LangGraph. In this LangGraph, right? So we have something on nodes. Each node, like if you think like a graph will have the nodes, and the nodes will be connected by the edges. So here in this section, I am creating the all the nodes. Like in this case, it's a perplexity, analysis, fact check, synthesis, quality check. These are all nodes I created. And whenever the search is happened, the entry point is the search. When I get the information from the, I used a Gradio library to get the input from the UI. So once I get the input, then I am calling this perplexity search. This perplexity search, once it done with the work, it will give to the analysis. This is another agent. This analysis will do complete its work and hand it over to the fact check. So this is an edge, right? So the fact check will do the fact checking and it will synthesize. Once the synthesis is done, it will do the quality check. See here the magic comes. The quality check, if it thinks it requires improvement, right? And the outcome can be like a improvement and improve, right? So if improve is needed, then it goes to the improvement, then it goes to the synthesis. So then it will again do the quality check and rerun that whole loop. So in this way you can determine like how you want to control your flow. This is the predefined workflow that I wanted to do. So but you can change it as per your requirements. Yep. So with this, let me show you the perplexity. So the currently I'm using the OpenAI SDK. It does not have direct support with the perplexity, but the other OpenAI that I use internally to for other API calls, that supports out of the box this. So I'm going to show you that. Yeah. So here I'm just opening. This chart OpenAI is provided by LangChain. So I'm just providing the prompt and other stuff. So the temperature, how randomly you want to generate, and the OpenAI key. This is a key. I stored all this key information in the environment variables. Then it creates this OpenAI SDK, right? So it will find out which model to use, preferred model also. So based on this model, like for one mini, I used the cheapest models available. So once I have this, I created an LLM and the perplexity tool. I created this as a tool, perplexity, and this is the memory. So you remember like each node, when it is passing the information to the next step, the information will be stored in the nodes in the memory. So and finally I'm creating the workflow. So this is how I created the workflow. And when I run this, it is running each step. And then I'm also checking either to continue or not based on the quality score. If it is greater than or equal to 0.75, then it will continue. And also I don't want to continue more than two times. So then I'm ending. If it is the third time, then it will come and stop. Yeah, let me show this how the execution flow happened, right, for this instance. Yeah. Yeah, let me go over this LangSmith. This is the observability, right, that I integrated with. So by just enabling some of the environment variables, we can plug in this observability provided by the LangChain. It's a called LangSmith. So first it made a call to the perplexity search. So input is latest development in the AI that we provide. Then the output it captured is like it got these many citations. So it went to these many sites to find out the information, and these are the search results. So it found out a lot of information here. Then it gave that input to the analysis, right? This analysis takes that input and it will run the analysis on this. So it got this query, like this is a query, and this is a research report got from the perplexity, and I'm giving this information to another agent, right? So then it gives the output. So it refines this, it did the analysis on the perplexity output. Then it gave uh, it gave the output to the next agent. Then the fact check is going to check the facts. So let me show you. So here, if you see that template, what is a prompt template I have used for this? So this is I built this prompt template for this, and if you see the system, like you are a professional fact checker, output bullet list the verified claims, questionable claims, source quality notes, and convents 1 to 10. It is going to score based on that. So it does this in a fact check, then it gave to the synthesis, right? The synthesis, like if you see, I'm using the GPT-401 mini and here also, but here I'm using the perplexity. So I'm using the multiple models inside this to orchestrate, to show how using the LangChain I can do this orchestration. And so the quality check is done, then it thinks that there are some improvements are there, then it will give that improvements thing, like these are the improvements needs to be done. Then the synthesis will do again the synthesis. So you remember that we can only call 3 times. So once it done the fourth time, then it is going to end that. So that the fourth time it is going to complete this. So the quality check is done, and it finally gave the output. That is how you see in the screen the final output. So maybe I can play around with some other. So here I take the another example of current breakthroughs in the quantum search, right? So I asked to do the research, and I'm going to showing the LangSmith how it is going to do the observability. Yeah, it started a new instance now, and it is doing the perplexity search. The input is given to this current breakthroughs in the quantum computing research. This is what we asked in the UA. So it may take a couple of seconds to complete the task. It is going to fetch, look in the internet, and it also lists what are the sites it visited. So these are such cool tools that we can build, like using the agent development. So and I'm running this in my local current in the current production, right? Generally the enterprise level, if you want to deploy these, we use like AWS and Azure, Bedrock, all these backend LLMs to call. And Orchestrator, we use LangChain, LangGraph, SDKs. So these are all industry level standards that we can use. I think due to time constraint, let me refresh the page and see that refreshes. Sometimes that it does not refresh automatically. If you see the perplexity search, right, it is using the sonar model, and also it is providing you the input and the output. Yeah, so this is how we build LangChain using LangChain, how we build the AI agent. So in the real time, we use this a lot. Uh, so with that, I'm going to conclude my demo. Thank you for attending this session. And if you have any question and answers, we can have a Q&A session next to if you have any questions. Thank you so much for your time.